Hi. This is the sort of AS level aspect when it comes to equilibrium constant. The rest of the other stuff, a lot of it's covered at GCSE as well. This will be brand new for AS. Before we start though, please like, subscribe, share, help me grow the channel. Any support is greatly appreciated. Let's get into it. So, equilibrium constant is a constant for reactions that are reversible, and this constant is different for every reaction, right? So this is something we can come to calculate. What we're going to look at today is just working out what the expression looks like and working out what our units are going to be. So let's use this first of all. So let's call this reaction. So we've got A plus B makes 2C plus D. Now, we use that, and we use reactions and moles, etc., to work out this value for Kc. And the way we do that is we do the concentration of our products multiplied by any moles divided by the concentration of reactants, again multiplied by any moles. So, in this case, let's see what our reaction would look like. So there, we're going to have the concentration of C. So whenever we see square brackets, that's what they mean. It means the concentration of C. Now, because you've got 2 moles of C, we will square this number, like so. Multiplied by the square roots, the concentration of D. So it'll look like that on the top. There are products. So again, we always need to think about products and reactants here. Divided by, this time, our reactants. So the concentration of A multiplied by the concentration of B. Now, all of these numbers are 1, right? So we don't need to add that, but if we were to, that would be fine, I guess. So then we'd sort of plug our values in, we'd work out our numbers. We'll look at that in a bit more detail in another video. What we do need to work out now is what our units look like. So here, a little bit of a refresher on how multiplying and dividing indices work. So here, A to the power of B times A to the power of C would be A to the power of B plus C, right? So if we had a little example here, if we had A squared multiplied by A, multiplied by A to the power of 4, that would be equivalent to A to the power of 6, right? Now, for divide, it works the opposite way around. So here, A to the power of B divided by A to the power of C is going to be A to the power of B minus C. So again, if we take that same example, maybe if we do it the other way around, A to the power of 4 divided by A to the power of 2, that's going to be A to the power of 2, right? Because we're doing our 4 minus our 2. And that's going to become important when it comes to working out what our units are. So if we take this example again, now we almost think about, we know what the units for concentration are. The units for concentration are moles per decimeter cubed. Per decimeter cubed. Now, in essence, we have 1, 2, 3 lots of moles per decimeter cubed, okay? 3 lots. Divided by, we've got 1, 2 lots of moles per decimeter cubed. Right? So, 2 lots, again, what do we do with those? We subtract them from each other. So we're left with none on the bottom, 1 on the top. So our units for this are moles per dm cubed, right? let's do a slightly different example. So let's do the same thing, but with different values here, right? So this time, let's say we've got 3 lots of A and 2 lots of B, okay? So this time, again, we're going to do the same thing. We've got our reactants, so we've got our Kc equals, and we've got our concentration of C, square root of that, plus D, sorry, not plus D, multiplied by the concentration of D. All of that is over concentration of A, this time cubed, multiplied by the concentration of B, this time squared. Again, to work out what these values in, we'd plug what our actual concentrations are and then work that out. Now, here, let's again show what this would look like to work out our units. So this time we've got, again, 1, 2, 3 lots of mole per decimetre cubed there. And we have 1, 2, 3, 4, 5 on the bottom. So this time, again, all of these will cancel this time, and we're left with 2 on the bottom. Again, 5 minus 3 gives us the 2. So what we're left with is 1 over our 2 lots of mole per decimetre cubed. Got 2 lots of those. Now, that means if you imagine we've got 2 lots of the 1, so we times this 2 by 1, so we've got 1 over mole to the 2, and 2 times the minus 3, so dm to the minus 6. The last thing we need to do is not leave it as a fraction, as 1 over, so we bring this to the top, and the way we do that is we invert our indices. So any positives become minuses, any minuses become positives. So that's the equivalent to mole to the minus 2 dm 6. Next, so one thing we need to think about, Kc is a constant, okay? Now it's only affected by one thing, it's affected by temperature. So there, all we need to, and again this is going to be reaction dependent. So there, what we need to think about is which way is the reaction going to shift, and what's that going to do to impact our value. What we'll do is we'll explore that in a couple of videos' time, but this is sort of a general idea is important to know. Let's do another example here, right? This time with actual elements, etc. So, again, Kc equals, we've got our concentration of our product, which is NH3, squared because of our 2 in front, all over our concentration of N2 multiplied by our concentration of H2 to the power of 3. Next we need to work out what our units are. We've got 2 lots of moles per decimetre cubed on top, and we've got 1, 2, 3, 4 on the bottom. So all of these cancel. We're only left with 2, which is equivalent to 1 over moles per decimetre cubed. And again, similar thing, right? We've got our 2 times 1, so we've got a 2 there, and then our 2 times -3 -6. And then we invert our units, mole to the -2 decimetre to the 6. Now, worth noting, hopefully you can see, if we had an example where we had equal moles on both sides, so say if this was 1, 1, 1, 1, then we'd have 2 lots of moles per decimetre cubed on both top and bottom, and hopefully you can see there'd be no units. So let's quickly do that. So say if we had A plus B makes C plus D. When it came to our units, A, B, excuse me, that would be on the bottom. C, D. This time, when we do our units, 2 on top, 2 on the bottom, all of these cancel, so that would be no units. So this is a case where if you got this kind of question in an exam, you would have to state that there were no units in the final bit. So what I'd like you to do now is give this a go. Again, work out what the KC expression would be, work out what the units would be, and see how you go. I'll answer that at the end of next video. For now, let's look at the same equation for this, right? So this time, again, let's think about all of our factors. So if we think about pressure first. So high pressure would shift the reaction in the left, right? Because we only have 1 mole on the left, 2 moles on the right. So high pressure would lead to a low yield. In terms of rate, high pressure would be a higher rate. And we also know high pressure is a high cost. So there, we're probably going to use a minimal amount of pressure, maybe a few ATM, right? So maybe 20 ATM. Again, this is really a guess, but it's showing that you've considered all of the different factors here. ATM, a compromise between rates and yield. Temperature. So this time our forward reaction is endothermic. We know that because it's positive. So if we heat this reaction up, our reaction is going to shift to the right. So high temp leads to a higher yield. High temp, we know, gives us a higher rate. But we also know a high temp is expensive. So, you know, maybe we're not going to heat to 1,000,000 degrees centigrade, but maybe we use 600 degrees centigrade as both high yield and rates, but a compromise considering cost. And I won't go into it, but if there was a catalyst, we'd absolutely use it. Hope that's helpful. Give the other question a go. What we'll look at next time is we'll look at how we're going to work out molar amounts when it comes to equilibrium and Kc. And then there'll be a third part that looks at how we do these final calculations. But I hope that's helpful. Give that a go, and I'll see you next time. Happy revising.